Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video lesson, I'm going to explain you how you're going to solve CIE 5070 past papers. So today I have selected specimen paper 2, which will be followed for examination from 2023 and onward. Let's begin with the question. Here's the first question. Choose from the list of oxides to answer the questions. Here's the list. You have calcium oxide, carbon dioxide, copper 2 oxide, silicon 2, silicon 4 oxide, sodium oxide, sulfur dioxide, sulfur trioxide, zinc oxide. Each oxide can be used once, more than once, or not at all. Identify which oxide A has a giant covalent structure. For this, we'll see the structures of all these oxides. Calcium oxide is an ionic compound. So ionic compounds have giant ionic structure or giant ionic lattice. So I will write here giant ionic. Calcium oxide is giant ionic. Carbon dioxide, simple structure. So you write simple. Copper 2 oxide, it's an ionic compound. Again, giant ionic, Gi. Silicon 4 oxide, it must have giant covalent structure. So I will write giant covalent structure here. You see the other options also. Sodium oxide, again, giant ionic. Sulfur dioxide, sulfur trioxide, both are simple. Zinc oxide, again, giant ionic. So for part A, the answer will be silicon 4 oxide. Part B reacts with acids and with alkalis. So this oxide must be reacting with both acids and alkali, and we have only one choice. If you look at all the choices, you have basic oxide, calcium oxide, carbon dioxide, acidic oxide, copper 2 oxide, basic, silicon 4 oxide, acidic, sodium oxide, basic, sulfur dioxide, sulfur trioxide, both are acidic. Zinc oxide is the only choice left. So it's the only oxide which reacts with both acid and alkalis. C is used in flue gas desulfurization. You can either have calcium oxide, copper 2 oxide, or sodium oxide. We know that copper 2 oxide is less reactive. It's not very much reactive. While sodium oxide is highly reactive, it reacts with everything. Calcium oxide is the oxide which is used in flue gas desulfurization for neutralization of acidic oxides. Calcium oxide. Part 4 contains a cation with a charge of +1. If you look at the cations, so where you will find cations. In this, you will find cation carrying, that is Ca, carries +2 charge. Copper, again cation, it will carry +2 charge. Any other cation? Yes, sodium oxide, it's Na plus. Zinc oxide, it is Zn +2. So the answer will be sodium oxide. Question number 2. Atoms and ions contain protons, neutrons, and electrons. Complete table 2.1. So this is the table 2.1, and there are some blanks. For instance, proton, you have to mention the mass of proton. Neutron, you have to write the charge for neutron. But for electron, you have to give the charge as well as mass of the electron. We know that proton has a mass of 1. and neutron does not carry any charge, so you write 0 here. What about the charge on electron? It's -1. For the mass of electron, the any fraction value between 1 by 1700 and 1 by 20, 2000. Sorry, 2000. So you can write 0 by 0.0005. Part B, table 2.1 shows some information about 6 particles. So part 1, deduce the nucleon number for particle A. For particle A, how you going to find the nucleon number for this? You will simply add up the protons and neutrons. That will be 37 plus 48. What you will get? You will get 85. Part 2, explain why particle B is a negative ion. Look at the number of protons and neutrons, number of protons and electrons for this particle B. If you look at this, 53 is the proton, 54 is the electron. So there's a difference between the number of electrons and protons. So you can write even has more electrons than protons. Has more electrons than protons. Part 3, identify 2 atoms that are isotopes of the same element. You have to find the 2 atoms in this that are isotopes of the same element. What are isotopes? Isotopes have same number of protons, different number of electrons. So if you look at these atoms, you'll find these having same proton number C, D, E. Now we'll look at the number of neutrons as well as number of electrons also, because if number of electrons different, then it must be the ion, not atom. So for D, if you look at the D, the number of electron is different. So you can't have D as the correct answer. So if you look at C and E, both have same number of proton but different number of neutrons. The number of electrons are also same. So answer will be C and E. So the answer will be this, and the explanation will be this: the same number of protons but different number of neutrons. Part 3, question number 3. Salts can be prepared by the reaction of acids and bases or alkalis, and also by precipitation reactions. A, state the ionic equation for the reaction between an acid and an alkali. Any acid and alkali, if you want to write the ionic equation, this ionic equation will remain same. That is the reaction between H positive ion coming from the acid and OH negative ion coming from the alkali. So, and the product will be H2O. Part B. Sodium sulfate is a soluble salt prepared by a titration method using an acid and an alkali. Identify the acid and the alkali used to prepare sodium sulfate. It's very easy. Sulfate, the sulfate ion is coming from acid, sulfuric acid. Sulfate from H2SO4. So you can write sulfuric acid. You can even write the formula of sulfuric acid, which is H2SO4. For alkali, sodium hydroxide is the answer. So NaOH or sodium hydroxide. C, aqueous sodium sulfate is used to prepare barium sulfate in a precipitation reaction. This is the ionic equation: Ba2 plus Aq, SO4 2 minus Aq gives PaSO4S. S means solid. In an experiment, 20 centimeter cube of 0.550 mole per dm cube of barium nitrate is added to an excess of sodium sulfate. Barium nitrate is limiting reagent, so we will use the data of this barium nitrate. State the color of the precipitate formed in the reaction. You have to write the color of the precipitate, that is BaSO4. It's always white, so we'll write white here. Now in 3 they are asking calculate the maximum mass of barium sulfate that could be made. First of all, you should know the number of moles of barium sulfate. If you look at this equation, so it's the reaction between sodium sulfate and barium nitrate. Sodium sulfate is Na2SO4 plus barium nitrate is BaNO3. One of the product is BaSO4. We are interested in BaSO4. We are not interested in the other product. If you look at the mole ratio, both BaNO3 and BaSO4, they have same ratio. BaNO3, BaSO4. So if you know the number of moles of BaNO3, then you can easily predict the moles of BaSO4 because it should be equal to BaNO3. 1 mole gives 1 mole of barium sulfate. So first, what we will do, we will calculate the number of moles of barium nitrate. I'm going to calculate the number of moles of barium nitrate from the data given. If you look at the data, 0.55 mole per dm cube means 1000 centimeter cube contains 0.550 moles. Therefore, 20 centimeter cube contains x mole. Do cross, you will get this x is equal to 0.550 multiplied by 20 divided by 1000. What will be the answer? 0.011 moles, which will be the moles of BaSO4. The MR of BaSO4 is given. So what you will do, you will multiply 0.011 by 233 to get the final answer. The final answer will be 2.563. This will be your final answer. A mass of 1.92 gram of dry barium sulfate is obtained. Calculate the percentage yield of barium sulfate. You will calculate the above data. It's very easy. .92 multiplied by 100, and the mass we have obtained is 2.563. So the answer should be between 74.9 or 75%. Question number 4. Calcium chloride CaCl2 is an ionic compound. Deduce the electronic configuration for each of the ions in calcium chloride. Now they are asking about the electronic configuration in ions. Calcium ion and chloride ion. Calcium ion will be Ca+2. If you recall the proton number of calcium, which is 20, so you have to subtract 2, you are left with 18. So what will be the electronic configuration? 2, 8, 8. What about chloride? Chlorine, its proton number is 17, which means 17 electrons. So it will get 1 electron to form Cl negative ion. So the same electronic configuration 2, 8, 8. B. When molten calcium chloride is electrolyzed with inert electrodes, calcium and chlorine are formed. Construct ionic half equations for the two electrode reactions. Reaction at the negative electrode. At negative electrode, what is moving? Positive ions are moving. There's a reduction taking place. Cathode, negative electrodes, cathode. So Ca+2 ion, it will take up 2 electrons to form Ca. What about positive electrode? That is anode. It's anode. That's cathode. Cl negative ion move towards anode and it will lose electrons to form Cl2 gas. Balance the equation, you will get this. The electrolysis of concentrated aqueous calcium chloride with inert electrodes is similar to that of concentrated aqueous sodium chloride. Predict the products of the electrolysis of concentrated aqueous calcium chloride with inert electrodes. We know that calcium and sodium both are above hydrogen in the reactivity series. So you can't get metals at the cathode. You will get hydrogen gas, H2, and as it is concentrated, so you'll get chlorine gas or Cl2. D. Calcium chloride has a high melting point. Explain why calcium chloride has a high melting point. Use ideas about structure and bonding. It's very easy when they are talking about the structure. It's giant lattice. Giant lattice. Straight away you'll write giant lattice. Now, bonding. Bonding is strong ionic. You can even write strong attraction between positive ion and negative ions. Question number 5, figure 5.1 shows the alcohols ethanol and butane 1-all. The figure, ethanol, butane 1-all. Describe the manufacture of ethanol from ethene. So you have to write the conditions. It's very easy. The reaction with steam will take place. Mention the name of the catalyst. That is phosphoric acid. Other condition, you have pressure and temperature if you want. But this is enough. These two is enough. Ethanol is used as a fuel. State one other use of ethanol. It's used as solvent or making vinegar. Or making vinegar. Construct a symbol equation to show the incomplete combustion of ethanol. It's very easy. Whenever you go for incomplete combustion of organic compounds, you will get two products. Steam or water will be the common product. The other product will be either carbon monoxide or carbon. So you have what will be the formula, molecular formula of ethanol is C2H6O plus O2. Combustion reaction involves the reaction between limited supply of oxygen and the organic compound CO or C plus H2O. You have to balance the equation. It's better if you write the balance equation. So if you are getting carbon monoxide, you write 2CO and water will be 3H2O. For carbon, it should be 2 carbon. Ethanol is oxidized to form ethanoic acid. State the name of a reagent that is used for this oxidation. It's very easy. You can write oxygen. Or you can even write acidified. Aqueous potassium manganate. It's 7. Part D. Draw the displayed formula of a different alcohol that is an isomer of butane 1-all. Now let's look at the structure of butane 1-all. I will draw the structure of butane 1-all here on the left hand side. This is the structure, right hand side. Structure of butane 1-all. 1, 2, 3, 4. It's 1-all, so you'll have OH on the first carbon. Now you have two options. You can either move this group to any other position or OH. You can make the isomer of butane 1-all. It's very easy. I'm going to show both. So if we move this CH3, we get this C1, 2, 3. Now if I'll change the position of functional group, that is OH. What I will get? I will get this. C1. One, two, three, four. I'm changing a position of OH. You can place it here and place hydrogen. These two are possible isomers of butane 1-ol. Butane 1-ol is heated with concentrated sulfuric acid, which acts as a catalyst. Butane 1-ene and one other compound are formed. Draw the structural formula of but 1-ene. But 1-ene, 4 carbon. 1, 2, 3, 4. So you write double bond between first two carbon atoms. Now complete the valency of carbon. Each carbon 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This will be the deduce the other compound form in this reaction. Water is produced in this reaction. State the type. Number F, but2ene CH3CH. CH3 is a polymerized to give polybutene. State the type of polymerization that occurs. It's additions, very easy. Number 2, draw the structure of polybutene showing at least one repeat unit. They are asking about showing one repeat unit for the polymer. We know that in polymers, there won't be any double bonds, addition reaction. So this will be the polymer, 1 unit for the polymer. A mixture of ethanoic acid, ethene, and oxygen is passed over a catalyst at 200 degrees centigrade to manufacture ethynyl ethanoate. This is ethynyl ethanoate, CH3COO, double bond CH2. And this is the reaction. The reaction is exothermic. Part A, draw a reaction pathway diagram for this reaction on figure 6.1. This is figure 6.1. On your diagram, label the axis, meaning that you have to label that both X and Y axis. The reactants and the products. The enthalpy change of the reaction delta H, the activation energy EA. This is an exothermic reaction. So the product will be at the lower energy state than the reactant. So we'll get, first of all, we will label the x-axis. On x-axis, you can even write progress of reaction. Or you can write extent of reaction. You can even write reaction coordinate. On a y-axis, we know that in energy or enthalpy. That's it. Both x and y-axis are labeled. Now, I'm drawing the reaction pathway. This is an exothermic reaction, so the reactants are at the higher energy state than product. So this is the reactant, and this is the product. You'll get energy hump like this. So on the reactant side, you will write the reactants, formula of all the reactants. On the product side, you will write the formula of all the products produced. Now, enthalpy change of the reaction. It's the difference between product and reactant, so you'll have enthalpy change here. This is the enthalpy change. Delta H, and it's negative. What about activation energy? Activation energy start from this line. Go in the highest level of this hump, energy hump. This is energy hump, and it's represented by EA. Sign will be plus. Remember, in activation energy is always positive. Either is exothermic reaction or endothermic reaction. You will get ECF if you draw the diagram for endothermic reaction. B. Explain why the enthalpy change of the reaction is exothermic. Use ideas about bond breaking and bond making. First of all, you write bond breaking. What's bond breaking? Bond making. Bond breaking is endothermic. And bond making is exothermic. A more energy released than absorbed. More energy released than absorbed. Now you are allowed to write heat instead of energy. You can use heat instead of energy. More heat. You can write heat. More heat released and absorbed. Question number 7. Peroxo disulfate ions S2O8 2 minus react with iodide ions in aqueous solution. This is a reaction. Iodide ions are oxidized in this reaction. You can see here it's oxidized because oxidation number decreases. Here it's -1 and on this side it is 0. So oxidation number increased or increases. State how the equation shows this. So looking at the equation, you can easily write iodide ions lose electron. Iodide, don't write iodine. Iodide ions lose electrons. Minus charge means it has one electron. So if it's moving to the 0 side, it means it has lost that electron. B. Table 7.1 shows how the relative rate of this reaction changes when different concentrations of peroxosulfate, disulfate ions and iodide ions are used. This table 7.1. These are the experiment. Experiment 1, 2, 3, 4, 5. You see the concentration of S2O82 minus in mole per dm cube. It's different. Similarly, the concentration of iodide I minus ion is also different. And related rate is also different. So what they are asking, using the information in table 7.1, describe how increasing the concentration of each of these ions affects the relative rate of reaction. First of all, see the peroxodisulfate ion. If you look at this, compare it, 0.008, 1.7 is the rate. For 0.016, doubling the concentration, what will be the rate? 3.3, 0.032, again, double the rate. So it's very easy. You can write for this one, increase rate or doubling concentration doubles the rate. Doubling concentration doubles the rate. What about iodide ion? Well, let's talk about iodide ion. Look at the concentration of iodide. 0.02 is 1.7. 0.02 again, it's increasing 3.3. Now if you increase 0.04, what's happening? Rate doubles. 1.7 to 3.4 doubles. 1.7 multiplied by 2, you will get 3. You will get you will get what? 3.4. Similarly, if you have 0.08 concentration of iodide ion, again the rate doubles. So 3.4 multiplied by 2 gives 6.8 and here it's 6.9. So the same, doubling concentration doubles the rate. doubling concentration doubles the rate. Iron 3 ions Fe3 plus catalyze this reaction. Explain how catalyst increase the rate of a reaction. How catalyst increase the rate of the reaction. It decreases the activation energy. So you'll write activation energy decreases. Activation energy decreases. So more particles have energy above that of the activation energy. More particles have energy above that of the activation energy. Above that of activation energy. Number 8. Copper reacts with concentrated nitric acid to form copper 2 nitrate. This is a reaction. State the meaning of aqueous. It's very easy. Aqueous means solution in water. AQ is aqueous. You can either write aqueous or solution in water. And some salt soluble in water, we'll write solution in water. Part B, an excess of copper is added to 25 centimeter cube of 6 mole per dm cube HNO3. HNO3 is nitric acid. Using this information together with the equation to calculate the volume of NO2 formed. The gas volume is measured at room temperature and pressure. Show your working and state the units. You have to show the working. So what we have? We have the volume and concentration of nitric acid. This is nitric acid. And we need the volume of nitrogen dioxide, NO2. So we need the moles of NO2. So I'll write here HNO3, 4 moles produces 2 moles. So first of all, we'll calculate the moles of acid, that is nitric acid. So according to the information, 1000 centimeter cube contains 16 moles. Therefore, 25 centimeter cube contains X. Do the cross, you will get what? X is equal to 16 multiplied by 25 divided by 1000. Okay. So you will get 0.4 moles of acid. So here you will have 0.4 moles of acid produces X moles. X is equal to 2 multiplied by 0.4 divided by 4, 1, 1. You will get 0.2 moles. Now you have the moles of NO2. You can easily calculate the volume. Simply multiply it to 24 by 24 dm cube. 0.2 multiplied by 24. So what you will get? You will get 4.8 dm cube. So your answer will be 4.8 dm cube. Or if you want to express it in centimeter cube, it will be 4,800 centimeter cube. When heated, CuNO3 decomposes to form CuNO2 and O2. Construct the symbol equation for this reaction. You have to write the balance equation. We know the formula of the reactant CuNO3. It's a decomposition reaction and produces CuO plus NO2 plus O2. So we have N is 2 moles on reactant side and on the product side it's 1. Oxygen is 6 and on the product side it's 5. So if I will write 2 before Cu, it will become 2 CuO, then 2 2 is 4, 4 NO2. What about oxygen? 2, 3 to 6, 6 to the 12, 4 to 8, 9, 10, 11, 12. Now it's balanced. The equation is balanced. D. To a small sample of CuNO3 whole twice aqueous, a student adds aqueous ammonia drop by drop until it is in excess. Describe what is observed. Blue precipitate or blue solid? Blue precipitate or blue solid. It's soluble in excess, so you'll get in excess becomes a dark blue solution. In excess, dark blue solution obtained. Part 2. The student repeats the experiment but adds aqueous sodium hydroxide instead of aqueous ammonia. Describe what is observed. Remember, again, you will get blue PPT of copper 2 plus ion, but this time it's insoluble. So you'll write what? You write, first of all, you'll write blue precipitate. Precipitate. Then you write which does not dissolve, insoluble in excess. Insoluble in excess of NaOH. 9. Iodine reacts with chlorine to form iodine 1 chloride ICl. Iodine 1 chloride reacts in a similar way to bromine. Iodine 1 chloride reacts with ethene in an addition reaction. Draw the displayed formula of the products of this reaction. Ethene. Recall the formula of ethene. The formula of ethene. You see the carbon-carbon double bond. So how it reacts with bromine? It reacts bromine in this way. It's an example of addition reaction. What you have to do, you have to add only bromine to both carbon atoms. Now they are mentioning here iodine 1 chloride reacts in a similar way to bromine. So it will be very easy to predict the product. Draw saturated form of ethene, which is ethane, and here you have ICl, so you write I and Cl. Very easy. B. Iodine 1 chloride reacts in a similar way to chlorine. Now, iodine 1 chloride reacts with ethane in a photochemical reaction in the presence of ultraviolet light. What will happen if chlorines reacted with ethane in a photochemical reaction? Is the formula of ethane C2H6. Whenever it reacts, it will produce a substitution product C2H5Cl plus HCl. So if ICl is reacting in a same way, so you can easily predict the product. First of all, state the type of reaction that takes place. The substitution reaction. Number 2, suggest a symbol equation for the reaction between iodine 1 chloride and ethane. Symbol equation. It's very easy. You can write either this C2H6 plus ICl. You can write any one of these. You can easily predict the product. Either C2H5Cl plus HI or C2H5I plus HCl. Both are correct. 9C. The dot and cross diagram for a molecule of iodine 1 chloride is similar to that for a molecule of chlorine. Draw the dot and cross diagram for a molecule of iodine 1 chloride. Show outer electrons only. Recall the diagram of chlorine molecule. It will be like this. Both contain 7 electrons in their valence shell and both need 1 electrons to complete their valence shell. 1, right? 2, 3, 4, 5, 6, 7. For this one, 1, 2, 3, 4, 5, 6, 7. Now here what you are having? You are having iodine chloride. Iodine chloride. We show the key. For iodine, I'm using dot. Chlorine, I'm using cross. Chlorine. 1, 2, 3, 4, 5, 6, 7. Iodine. 1, 2, 3, 4, 5, 6, 7. CZ. D. Iodine 1 chloride reacts with chlorine to form iodine 3 chloride. The reaction is investigated at 200 degrees centigrade in a closed system. The reversal reaction reaches an equilibrium. This is the reaction. Describe two features of a reversible reaction equilibrium in a closed system. In your answer, refer to the rate of reaction and to the concentration of the reactants and product. It's very easy. In any reversible reaction reaching to a dynamic equilibrium state in a closed system will always have rate of forward reaction equal to rate of backward reaction. So you can write rate of forward reaction is the same as the rate of backward reaction, as the rate of backward reaction. And the concentration of reactants and products do not change or remain constant. The concentrations of reactants and products do not change. Can even write remain same. Number two, the pressure of the equilibrium mixture is increased. The temperature is kept at 200 degrees centigrade. ICLG gas is a dark brown gas. ICL3 gas is a yellow gas. Predict and explain what will happen to the color of the equilibrium mixture. First of all, you have to predict. So look at the number of moles. So if you're increasing the pressure, the equilibrium will shift towards the side in which there will be less number of moles of gas. So on the reactant side, there are 2 moles. 2 moles on the reactant side and 1 mole on the product side. So it will move to this direction. Equilibrium shift to right side, the product side. The product side is ICL3. Solution of color becomes more yellow. Color becomes more yellow. Or you can write the color becomes less brown, or color becomes less brown. You can even write goes yellow, it's yellow. So what will be the explanation? Fewer moles on the right hand side. Fewer moles on right hand side. On right hand side. So the position, position of equilibrium move to the right. Move to the right. Question number 10. Air contains a mixture of gases including the noble gases, neon, argon, krypton, and xenon. These noble gases are monatomic elements. State what is meant by monatomic. Exist as atoms. Atoms unbonded. Atoms unbonded or exist as atoms. B. State why noble gases are unreactive. You can write complete valence shell, stable outer octet. Complete valence shell or has a stable electronic arrangement or has a stable electronic configuration. C. State why fractional distillation can be used to separate a liquid mixture of neon, argon, krypton Xenons, very easy, have different boiling points. They have different boiling point because the theory is based on the different the boiling point of liquids. D. State which noble gas, neon, argon, krypton, and xenon has a faster rate of diffusion at 200 degrees centigrade. Look at the mass. Neon is the only choice because it has low mass. So you write in the explanation, smallest relative mass has the smallest relative atomic mass. The air also contains oxides of nitrogen that are pollutants. State one adverse effects of oxides of nitrogen in the air. Photochemical smog or acid rain? Acid rain or photochemical smog. You are even allowed to write ozone depletion. Number two, with the aid of symbol or word equation, explain how oxides of nitrogen such as NO are formed within a car engine. The reaction between nitrogen and oxygen, N2 plus O2, what you will get? You will get 2NO. You can write the word equation for this and the condition spark or high temperature. Spark or high temperature. Number 11. Table 11.1 shows some information about the homologous series of unbranched carboxylic acid. This is unbranched carboxylic acids. One of the characteristics of homologous series is that it has a general formula. To deduce the general formula for the homologous series of unbranched carboxylic acid, you have to recall this CnH2n plus 1 COOH. Part 2. Describe two other characteristics of homologous series. You can write any of these series like they have same functional group, or they have what? Same chemical properties, same method of preparation, idea that each member differs by CH2 group, member differs by CH2 group. You can even talk about physical trend in physical properties. Part B, an aqueous solution of propanoic acid is a weak acid. Define the term acid. Easy. Release hydrogen ion. Butanoic acid reacts with ethanol to make an ester. State the name of the ester made and draw the discrete formula of the ester linkage. It's very easy. The alkyl group comes from the alcohol. Alkyl alkanoate. You'll get alkyl alkanoate is coming from alcohol and alkanoate is coming from carboxylic acid. So you'll get what? Ethyl butanoate. The split formula will be like this. 4 carbon for butanoic. 1, 2, 3, 4. 2 for ethyl, showing each hydrogen atoms. Ethanoic acid is a liquid at room temperature. Describe the changes in arrangement and movement of molecule of ethanoic acid when it's heated from room temperature to 120 degrees centigrade. So 3 marks question. The molecules have more kinetic energy as temperature increases. Molecules have more kinetic energy. First of all, you write this. Second thing, the further apart at temperature increases. Molecules further apart as temperature increases. Last point, they are arranged more randomly, or you can write more irregularly. Molecules arrange more irregularly as temperature increases. Thanks for watching. Please like, share, and subscribe my channel. For more videos, subscribe to my channel.